Hello class, today we are going to be learning about histograms. So in your notes, if you'll please find 1.5 histograms. It starts on the page that says 1.4 at the top. So your job today is that you can interpret information presented in a histogram and that you can construct a frequency table which you'll use to then construct a histogram when I give you a set of data. So first we're going to watch a video that will introduce the idea of a histogram to you. So this part is not in your notes, I just want you to follow along with the video.
He explained. Imagine we went out and measured someone, and they were this tall. And then we measured someone else. And then we measured a whole bunch of people. We've measured so many people that the dots overlap. Some dots are completely hidden. We could try to make it easier to see the hidden measurements by stacking any that are exactly the same. But measurements that are the exact same are rare, and a lot of the hidden measurements are still hidden. So, instead of stacking measurements that are the exact same, we divide the range of values into bins and stack the measurements that fall in the same bin. This, my friends, is a histogram. Bam.
Alright, so when we're making a histogram, we're using data that is continuous. So in your notes, I want you to find the box that says uses and write this down. We use a histogram to look at the distribution, or how spread out the data is, for continuous numerical data. So anything where we have a numerical answer, we can put into a histogram. We use histograms for grades, we use histograms for height and weight, we use histograms for income, and anything else that has a numerical data point. We would not use a histogram for things that are categories, like what degree you have, or what your favorite pizza is. Those things would have to go onto a bar graph. Now, when we look at a histogram and we look at the distribution, we can tell a few things. I can tell that this area right here is the most common. And if I measure somebody, it's really likely that they are going to fall into this category. These ends are smaller, they're shorter. These are more rare. So it's less likely that I measure somebody else and they fall into these categories. And so I can use the data as a form of making a prediction about the next person. So in this histogram, it's skewed to the left. We have more data on the left-hand side. So I can see that it's more common to be short and it's rare to be tall. And that gives me information about the data, in this case, the height of the person. Right, in this particular histogram, and this is what most histograms look like. We don't usually use the circles, we use bars. And notice that the bars are touching, okay? Unlike a bar graph where we have space between the bars. We have bins, and these bins are about 0.4 apart from each other. And this is measuring weight. So I can see that the most common weight of this item is 60 grams. And I would expect things to be in this area. This is the most common. Over here and over here are the least common. And that gives me information about what to expect for the weight of whatever item this is measuring. Now notice, just like on our previous graphs, we have a title. We have a title for the y-axis, and this will almost always be frequency. And then on the bottom, we have our intervals and labeled the weight, so we know what those intervals represent. So we're going to make a histogram now and a frequency chart. So what will often happen is you'll be given a set of data like this. And before you can make the histogram, you need to decide on what your bins are going to be and count how many you have in each bin. So in this problem, we've decided on a bin size of 5, so we're going from 5 to 10, 10 to 15, 15 to 20, and so on. Now, one thing that you need to be aware of is where do you put a number like 10? So I want you to go through and I want you to circle all of the numbers on the left. 5, 10, 15, 20, 25. So numbers that fall in on the line like 10 or 15 or 20 always go in the one that you circled, on the one that's on the left. Now the other thing I need you to do is I need you to cross out this 29. It's an extra value point. We did not need it for this problem. So when I go through and I do the frequency, often what I do so that I don't miss numbers is I go in order of my data list. So I start at 6 and I do tally marks first. So 6 would go in 5 to 10 and then I can cross that off. I go to the next number. 15 is on the line and it goes in the one that I circled, the number where the 15 is on the left. So 15 goes here. 21 goes here. 25 goes in the second one, the one that's circled. 16, 21, 26, 7, 7. Okay, and by going in order of the data points, that just helps me not miss any numbers. 16, 9, 21, 26, 26. 10, excuse me, that is the wrong spot. Remember 10 goes, if it's on the line, it goes in the one that we circled, the one when it's on the left-hand side. 12, 17, 18, 24, 17, 27. All right, so now we've entered all of our data. Then I just want to go in and write these out. So there's 4 here, 2, 6, 4, and 5. Now when you add these up, we should get 21, and that equals the number of data points. So you can double check again and go through and count how many are on your list. We get 21, which matches our total here, and that just reassures me that we didn't miss any of the totals. Now what we do next is we come over to our graph and we label our graph. So this one is the gallons of gas purchased, and that was given to you on your notes. So I title this gallons of gas. Okay. The y-axis, the vertical one, is always going to be labeled frequency. Okay, how many times that occurred for each range. Across the bottom, we're going to label our intervals, and in this case, our intervals represent gallons of gas. So we're going to label this gallons. Now when I label this, I label it like a number line. So instead of writing 5 to 10, 10 to 15, 15 to 20, I'm just going to start at 0 and go 0. Actually, you can start at 5. That would be fine. So go 5 to 10, 15, 20, 25, 30. That way, it looks like a number line, and you don't have the duplicates, and it makes it look very continuous. So now we draw our bars. Remember, this time our bars are going to be touching. We need to label our frequency side. So our biggest number was a 6. So I need to be able to count up to 6 on this side. In this case, because we have 1, 2, 3, 4, 5, 6 lines, it is okay to count by ones. Sometimes you might have to count by 2s or by 5s to be able to fit your frequency on your table. All right, so now we start drawing our bars. Now because our bins are all the same size, the width of our bars should be the same width, as close as possible. All right, so now we have all of the parts of our histogram. So I'm going to have you pause the video and just give everyone a minute to get caught up, make sure they have this on their notes. And then we'll talk about how to interpret that and answer questions about this histogram. All right, things that I would like you to remember. Okay? I want you to write down 2 things because the rest of these are things that we remember for every graph. But we need to add that there are no gaps, and a data point that's on the cutoff always goes in the next bigger bin. So if you have 5 to 10 and 10 to 15, the bigger bin is the 10 to 15. So it always goes in the next bin. All right, so now we're going to answer the interpreting questions that are on the right-hand side of your notes. Okay. So looking at our histogram, most drivers purchase between blank and blank gallons of gas. So most is the bar that is the tallest. So we're looking right here. Most of them would buy between 15 and 20 gallons of gas per week. How many drivers purchase between 10 and 15 gallons? So I come to my graph. 10 to 15 means I'm looking at this bar right here. And there were 2 drivers. Question 3, how many drivers purchase between 10 and 20 gallons of gas? So that is this column and this column, so I need to add those together. There's 2 and 6, so a total of 8 drivers. All right, I would like you to pause the video again, and I want you to answer questions 4 through 6, and then we'll check your answers. All right, question 4, how many people purchase 20 or more gallons of gas? So that's cut off right here, or more is the rest of them, so we add these 2 columns together, and we should have 9 people. How many drivers are represented in this histogram? We already counted that earlier, but if you had just the histogram and not the data, you would add up all the numbers. 4 plus 2 plus 6 plus 4 plus 5. 21 people. If we added a driver who got 15 gallons of gas, which column would you put it in? So if we were adding an additional data point, he got 15 gallons of gas, because that's on the cutoff, we would put it in this category right here, 15 to 20. All right, we're going to do some partner practice, so I'd like you to turn and work with your partner if they're here. If not, turn and look around you and join another group to make a group of 3, or see if somebody else near you does not have a partner as well. So we're going to pause the video one last time, and I want you to go and discuss with your partner questions 1, 2, and 3. All right, you've discussed with your partner. We're just going to check your guys' answers. So most black cherry trees are blank to blank feet tall. Remember, most is the tallest category. So we would say 75 to 80 feet tall. What size bins are being used? So we're looking at the interval from here to between the numbers here. And these are all 5 units apart, so we would say 5. If we wanted to add a tree that is 80 feet tall to the graph, which bin would you add it to? Because it's on the cutoff, it goes into the next bin, so 80 to 85. All right, for your assignment today, you have 4 sections. The first one is I give you a histogram and you answer some questions about it. The second one is I give you a frequency table that's already filled out and you make the histogram. And then on the back, you're going to make frequency charts and histograms for 2 sets of data. If you have any questions, please ask the sub. She will be able to help you. And this assignment is due at the end of class. When you are finished, please correct it, fix any mistakes, put a score on the top, and turn it into the box. And I will see you guys tomorrow.